My name is Gerrard Nyadang ANAK UMPOH, matrix number CD240216.
My name is DESMOND EDDY and ANSI, and my matrix number is CD240129.
My name is DOWEN and DECKIE, and my matrix number is CD240186.
My name is CHENG, number matrix CD240286.
My name is Jerome and PATRICT, and my matrix number is CD240023.
Firstly, I will explain the introduction. In the field of physics, statics refer to the segment of mechanics that examine the forces acting on objects that are stationary and in a state of equilibrium. The insight and result obtained from the study of statics are crucial for the engineering of structures such as buildings, bridges, and dams, as well as mechanical devices like cranes. Engineers and architects must first assess the forces that affect the interconnected element of this machine and structures to accurately determine their required dimension. Statics provide the analytical and graphical method needed to identify and characterize these unknown forces. Okay, the second one is objective. The first objective is to utilize principles of mathematics, science, engineering fundamentals, and mechanics to address challenges in static engineering. The second one is to know static engineering problems and arrive at well-founded conclusions using the foundational principles of engineering mechanics. And the last one is to make contribution both as an individual and as a participant or leader within diverse teams in a multidisciplinary environment when tackling statics engineering issue.
So here are the part for 2.0 literature review. So 2.1 theories of rigid body. Analysis and comprehension of the equilibrium of things that are thought to be fully rigid, that is, that do not deform when subjected to external forces or moments, are the main goals of the theory of rigid body statics. According to this theory, an idealized rigid body simplifies the study of forces and moments by maintaining constant distance between any 2 points within the body. The fundamental idea is the condition of equilibrium, which asserts that all forces and moments acting on a rigid body must equal zero. It is also includes ideas such as the classification of support and reaction, such as permanent supports, pins, and rollers, which offer limitation to preserve equilibrium, and free body diagram, which graphically depict all external forces and moments acting on the body. It also takes into account the distributed forces such as uniform loads or self-weight, and how these affect internal stresses and moments. In mechanical engineering, the theory forms the basis for evaluating machine, structures, and systems to guarantee their stability, functioning, and safety under varied loading scenarios. So for 2.2, equation of rigid body. In the study of rigid body statics, the equilibrium equations are fundamentals for assessing the forces and moments that influence a body. Below are the primary equations utilized in this field. Equilibrium equation for a rigid body that have two. For the first one is force equilibrium, and the number 2 is moment top equilibrium. And for 2.3, are the application of a rigid body. So the first one is structural analysis. We are calculating the forces in the beam, frame and trusses. For the second one, support reaction. We are determining reaction at support, for example like hinge, roller and fixed support. For the third, friction analysis. We are doing the solving the problem like involve static friction. And for the fourth one is the center of mass and stability. We are doing the stability condition and analyze the balance.
Okay, for 3.0 problem definition, our example is a crane. So a crane is a machine used to lifting materials both vertically and horizontally, utilizing a system of a boom, hose, wire ropes or chains, and ships for lifting and relocating heavy objects within the swing of each boom, lifting hook or platform, a counterweight, and a mechanical system. Cranes are frequently seen in industrial environments, maritime ports, and building sites.
4.0 Mathematical modeling. The first figure shows the picture of the boom, and the next to it is the free body diagram, including all the important points which will help involving inside the calculation. 5.0 is our result for the calculation of the boom. So for FAY, the total force is negative 24,834.4 Newton, which is in a vertical component. And for the FBC, the total force is 27,734.4 Newton, which is also in a compression.
For now, we continue with the discussion. Rigid body static examined how external force and torques affect rigid body without causing sum of motion, with equilibrium being a key of concept. For a rigid body to remain its static equilibrium, the sum of external forces and torques must equal to 0, preventing translational or rotational motion. Free body diagrams are crucial tools that help visualize and analyze this force, while the concept of torque couples equals but opposite force producing pure rotation with translation is essential for understanding rotational dynamics. In the concepts of the jib crane operation, maintaining equilibrium ensures stability and safety. Vertical equilibrium requires the tension in the support cable to balance the combined weight of the crane and load, while horizontal equilibrium ensures that the force like friction and wind cancel to prevent sideways movement. Rotational equilibrium demands that moment around any point are balanced, maintaining the crane stability. This equilibrium principle guide a crane design and operation, helping prevent overloading, tipping, or unaided movement, while enhancing structural integrity and operational safety. Last part, which is conclusion. All in all, the examination of a static cornering rigid body provides essential insight into a requirement of equilibrium that the forces acting on the steel objects. Static allow us to analyze and forecast the behavior of a solid in a state of balance. This is accomplished by studying the equilibrium of forces and moment that affect the body. The field of a static investigates the stability of various structures and its objects. Its aids is ensuring whether a rigid body will stay equilibrium or if will be tipped or fail when subjected to the external forces. The idea of center of mass, which indicates the point where the total mass of the objects is to be concentrated, is crucial in static of a rigid body. The point is vital for evaluating a system transitional equilibrium. For engineers and scientists, graphing the principle of static in a rigid body is essential for designing the evaluating structures and systems that equilibriums. It serves a groundwork for future study in dynamics, shifting the emphasis to motion of a body affected by the forces. Static is a crucial foundation for understanding and physical world, and it is fundamental aspect to the advancement and refinement of the engineering principle and application. That's all from us. Thank you very much.